Okay, so we have trigonometry lesson 1. So there's 2 chapters on trigonometry. One involves graphs and equations and is more similar to what you would have done last year. And the second chapter on trigonometry is called trig identities, and that's what that whole big chunk is on our formula sheet. So today's lesson is really an introduction. It has a whole bunch of definitions that we're going to use as we work through these chapters. So rotation angles and standard position. Angles can be measured in degrees, where 360 degrees is one complete rotation. A rotation angle is formed by rotating an initial arm through an angle theta degrees about a fixed point. So if you originally picture that you have 2 lines overlapping, and then the one opens up, and that's how we get our angle. The angle shown in the diagram is said to be in standard position. On a coordinate grid, standard position means the initial arm is along the positive x-axis and rotation about the origin. A positive angle results from counterclockwise rotation. So for example, here we have a degree of positive 235 to go from there to there. A negative angle results from clockwise rotation. So the diagram below shows negative 247. So we always start at the positive x-axis. This time we went clockwise, so that is a negative angle. So example 1, sketch the rotation angle in standard position and state the quadrant in which the angle terminates. So remember, our quadrant numbers are numbered like this: 1, 2, 3, 4. So 290 degrees, that's positive, so we're going to start and we're going to go counterclockwise. Well, this is 270, so we have to go about 20 degrees further. So this is 20 degrees from here. So it is in quadrant 4, and this is our angle of positive 290 degrees. So the next one here, negative 135. So now we're going to go this way. Well, to here would be 90, or negative 90. All the way to the next axis would be negative 180. So we're going to be somewhere in between there. Right, and if this is negative 90 degrees, to get to negative 35, this would have to be a 45 degree angle here. And this, what quadrant does it terminate in? Quadrant 3. 750. So we can go around and around as many times as we want. We need this to be positive 750. So we're going to go counterclockwise. We do one full rotation. That's 360. We do a second full rotation. That's 720. Then 30 degrees more. So this would have to be a 30 degree angle, is in quadrant 1, and that gives us our angle of 750. Example 2, the point A lies on the terminal arm of the rotation angle theta degrees. In each case, draw the angle theta degrees in standard position. So sometimes they'll describe an angle to us by giving us a point on the terminal arm. So these are just x and y coordinates. So x of negative 3, y of 4, we have a point there. To demonstrate the angle, we go like that. Now, what angle is this actually describing? Remember, it's always connected to the positive x-axis. So we're describing that angle there. So next one, negative 7, negative 2. Well, negative 7, negative 2 would be somewhere over here. So we're just having, this is our terminal arm. So our angle then always starts at the positive x-axis to the terminal arm, is right there. Okay, our next definition is coterminal angles. Draw the rotation angle in standard position. So first angle we have to draw here is 150, positive 150, so that's over here. Negative 210. Well, positive 150 ended up 30 degrees from here. Negative 210 ends up in the same spot. We just get there by going the other direction. Rotation of 510. Again, we do one full lap. And then we end up back here where this angle would have to be 30 degrees. So if you'll notice that all of these end up in the exact same spot, even though they had a different measure, and these are then called coterminal angles. So we have different ways of getting to the same spot. They're called coterminal because they all overlap. The principal angle of a set of coterminal angles is the smallest positive rotational angle within the same terminal arm. So the smallest positive angle is what we call the principal angle. The principal angle is always between 0 and 360. So in the diagram above, the principal angle is 150 degrees. There are infinitely many angles that are coterminal with a given angle. They can be found by adding or subtracting multiples of 360 degrees to from the given angle. The set of all coterminal angles can be described with reference to the principal angle P as P plus 360m. So basically we can go 360 degrees either direction, and we're always going to overlap with the same arms. The set of angles coterminal with the angles in the diagram above can be written in the form 150 degrees plus or minus 360n, where n is an integer. Right, so if n is -1, this means we start at 150 and we do one full rotation clockwise, and we're going to overlap again with our same angle. If n is +1, we'd go counterclockwise and we'd overlap again. When n is 0, that would give us our principal angle of 150. Example 3, in each case determine the angle theta in the domain between -360 and 360, which is coterminal with the given angles. Write an expression involving the principal angle that represents all of the angles that are coterminal with the given angle. So 285, to represent one between -360 and 360, we could subtract 360 degrees, giving us the angle -75. That would be coterminal. To describe all of them, we have 285 degrees plus or minus 360n. We should always specify that n is an integer because n needs to be an integer. If it can't be something like 2.5, because then it wouldn't be coterminal if we're not doing full rotations. So -13, to get a coterminal angle between -360 and 360. In this case, we'd have to add 360, which is 347. And to describe all of them, -13 degrees plus minus 360n, where n is an integer. Last one, we'll subtract 360, which gives us a coterminal angle of 35. And then we have 395 plus 360n, where n is an integer. Okay, the next thing we need to talk about is reference angles. And this is what we use the most in this unit. So almost every question we're going to do, we're going to be talking about the reference angle. So reference angle is the acute angle formed between the terminal arm of the rotational angle and the x-axis. So acute means less than 90. So this is always the angle between your terminal arm and the closest spot on the x-axis. So the diagram shows the terminal arm of a rotational angle of 120 degrees. Mark 120 and 60 on the reference angle, with a reference angle of 60, sorry. So this is our angle from here to here is 120 degrees. This portion here is 60. The acute angle, that is our reference angle, would be this angle of 60. So example 4. In each case, sketch the rotation angle and state the reference angle. So 243, we know that this is 180, 243 is somewhere here. Our reference angle is going to be here, to the closest spot on the x-axis. So we could take our 243 minus 180. That's going to give us our reference angle of 63 degrees. The second one, 337. 337 ends up here. Our reference angle is now here. Now we go to the other part of the x-axis because that's what's closer. To find our reference angle there, we'd go 360 minus 337, which gives us 23 as a reference angle. Last one, 70 degrees is here. In this case, our reference angle is simply 70 degrees. So if a terminal arm is in the first quadrant, it's really just the same as the angle. The diagram below describes the relationship between the reference angle and the rotation angle in each quadrant if the rotation angle is between 0 and 360 degrees. It needs to be converted to the principal angle for the relationship to be valid. So again, we usually work with the principal angle, so something between 0 and 360. And then we can use these rules, but I really find it's quite obvious. So if your terminal arm's in quadrant 1, the rotational angle is equal to the reference angle. If your terminal arm is in quadrant 2, you can go 180 minus the reference angle. If you're in quadrant 3, your rotational angle is 180 plus the reference angle. And in quadrant 4, your rotation angle is 360 minus the reference angle. You can memorize these if you need to, but personally I find it more confusing to memorize them and what this is saying than just looking at the picture and finding the reference angle.